Hello, our next topic is what are ionic compounds? And this is part of the nomenclature series, and it is the second video in the series. So we're going to actually look at what are these things today. So we have a little grumpy cat over there. People said I had to be positive, so I lost an electron. Therefore, he became a cation, grumpy cat. Whoa. All right, first off, I just want you to see that ionic compounds, like what are they? Let me move my face here a little bit. What are ionic compounds? And ionic compounds contain a metal plus a nonmetal, where they have a cation plus an anion because they must give and take. So therefore, there's going to be an electron loss and an electron gained. These ionic compounds are held together by an attraction. It's not necessarily a force, it's not like a gravitational force or anything like that. It's simply an attraction. One electron from one atom is actually attracted to the protons or the nucleus of another atom. That's where the attraction comes in. And finally, the electrons are taken and given. And notice I put given in quotes because it's not always like, oh, here's my electron, you can have it. It's more like, give me all your electrons, and that atom that gives the electrons can really do nothing about that. So if you guys have ever watched James Bond, you'll see this little joke, the name's Bond, ionic bond, taken, not shared. So if you watch the movie, it says shaken, not stirred. So if you haven't watched the movie, you should. Whoops. Okay, so ionic compounds contain ions that are held together by attractive forces among the oppositely charged ions. So what I want you to see here is, oh my, there's a Lewis structure. Looky there, we have an Na with one valence electron and a chlorine with 7. So what's going to happen is that chlorine very much wants this one valence electron. So this one valence electron is actually going to go here. Chlorine's going to grab onto it, and therefore chlorine's going to hold sodium right next to it. Now, if you look over here in this structure, you're going to see that sodium and chloride make this beautiful structure here. And notice that the cations are actually much smaller than some of the anions in this particular picture, because let's think about this with ionic radius. So we know with an anion, the ionic radius actually has more electrons than protons. So therefore, it's going to be a little bit larger. So that's why chlorine is shown as being larger, where sodium is shown as being smaller, because we go back to the trend of atomic radii and ionic radius. Notice also that it's like a pattern where the NAs fill in between the Cls and the Cls fill in between the NAs, and that's how they're held together by this attractive force. Another example of how ionic compounds form, here's some aluminum oxide here in the corner, just so you kind of know what aluminum oxide actually looks like. But what's happening here is oxygen is basically going to take the 2 electrons from aluminum. And if oxygen takes 2 electrons and it has gained 2 electrons, it becomes a 2- charge. Now notice aluminum still has an extra electron over here. So what's going to happen is another oxygen, and I'm going to use the Lewis structure. Now oxygen has 6 valence electrons, so I'm going to draw those 6 valence electrons in. And aluminum, oxygen is going to take this electron from aluminum. Now if aluminum gives up 3 electrons, it becomes a 3+. But now oxygen needs another electron. So what's going to happen is good old aluminum. It's going to go after another aluminum atom. And aluminum has 3 valence electrons. So that one of those electrons is going to go to oxygen to fill oxygen's outer edge orbital. Since oxygen took or gained 2 electrons, it now becomes a 2- charge. And now aluminum has 2 electrons left. So what's going to happen is an oxygen is going to take this. Okay, and an oxygen, I drew it to have 6 valence electrons. And so aluminum, oxygen will take this one. Oxygen will take this one. Aluminum now has lost 3 electrons, and this oxygen's gained 2. Now, guys, this looks like a mess. I realize that. But what I want you to see is if you actually add 2 minus plus 2 minus plus 2 minus, that's a minus 6. And then you add 3 plus and 3 plus, that's a plus 6. So we have an overall charge now of 0. Now, how many aluminums did we actually write out there? How many aluminums? We have 1 aluminum here, 2 aluminum. So we have 2 aluminums. And how many oxygens? 1, 2, 3 oxygens. We have 3 oxygens. When I go to write my compound, I always write my metal first. So I have my aluminum, and I'm going to write the number of aluminums I have as a subscript. And then I write my oxygen, and I write the number of oxygens I have as a subscript. So here's the chemical formula for aluminum oxide, and we got it from drawing it out. Now, thank the good Lord, you do not have to do this every time you try to put together an ionic compound. I'm sure you're dancing right now knowing that. So we can determine the chemical formula way easier than having to draw it all out. I do like to show you how to draw it all out because it helps you understand what's really going on. But what I want you to think about are the common charges using the periodic table. So if you look at the periodic table, you're going to see the charges at the top, and you have these written on your periodic table. And these charges are the charges in the rows that these will actually most likely make. So what we do is we can consult the periodic table to find those charges. So how are we going to write an ionic chemical formula without drawing it all? So first, we have to determine the charge on the metal and the nonmetal, assuming that they're ionizing, because when they're together, one atom will give up electrons and one atom will take those electrons. Then we do something called crisscross applesauce, and we be sure the subscripts are written in lowest terms, like when you reduce fractions. So let's try one. Let's try to put magnesium and nitrogen together. So we write out magnesium and we write out nitrogen, and the metal always goes first in the chemical formula. So on the periodic table, magnesium is where it would make a 2 plus charge. And nitrogen is where you'd make a 3 minus charge. So this is not the valence electrons. This is the charges that they would make. So what we do is we crisscross applesauce to bring the charges down as subscripts, but we don't bring the plus or minus sign. So then we would have Mg3 N2, and nothing else can divide into 3 and 2, so this is in its lowest terms for magnesium and nitrogen when it forms a compound. Here's another example, calcium and fluorine. We always write the metal first, so let's find calcium on the periodic table. It's right under magnesium, so we're going to have a 2 plus charge. Let's find fluorine on the periodic table. It's a -1 charge. So if we crisscross applesauce and we bring the charges down as subscripts, calcium, we're not going to write the subscript 1. We just assume that it's 1 if calcium's written. But we will write for fluorine, we'll bring that 2 down. So we have CaF2. Here's one more example with aluminum, Al, and nitrogen, N. Again, we write the metal first. We find aluminum on the periodic table. It's a +3 charge. So +3. We find nitrogen on the periodic table. It's a -3 charge. So what we do is we crisscross again. And so officially we would get Al3N3. But just like with fractions, if we would have 3 and 3, well, both of those can be reduced or divided by 3. So our final answer would be ALN. Now I want you to try, and so I'll put up an example, and then I'll pause, and I want you to pause, and then I'll go over the answer with you. Strontium and chloride, or chlorine in this example. Okay, gallium and oxygen, potassium and nitrogen. Now let me go through these with you together. Oops. So we have strontium, Sr. Again, we write the metal first, and chlorine, Cl. I'm sorry, that probably should be an N right there instead. Strontium on the periodic table is a 2+ charge. Chlorine is a -1 charge. So I crisscross, and I get Sr. I'm not going to put my 1 there because it's just assumed that it's 1. Cl2. Gallium and oxygen, so I have Ga and O. Ga on my periodic table is right under aluminum, so it's going to make a 3+ charge. Oxygen is O, and it's right here under my 2-. It'll make a 2- charge. If I crisscross and bring these charges down, I'm going to have Ga2O3. And finally, potassium and nitrogen. So I always, again, write the metal first. Potassium simply has a +1 charge. Nitrogen has a -3 charge. So if I crisscross, I'm going to have K3N. Don't make this harder than what it needs to be, and we will be ready to name these.